So what do you do when you find out that you're using a test instrument with a non-calibrated display? Do you fret or do you rejoice? Well, you should rejoice because that means you have a test instrument that has a lot of flexibility in the type of tests that you perform. A calibrated display is one that is calibrated for a specific type of measurement. For example, if you had a conductivity meter that had percent IX listed on the meter, that would be a calibrated display for measuring conductivity and IX. However, it's likely that that's all that your instrument is capable of testing is conductivity and IX. Same way, if you had a meter that had resistivity in microohm centimeters, that would be a calibrated display to measure resistivity. Now, what about this locator over here? That's also a non-calibrated display. That doesn't mean the instrument failed its annual calibration. It just means that it's not set up for any particular test, giving the operator the flexibility to test for a variety of things. And you can do that on either one of these testers. Now, if you have an uncalibrated display, then how can you calibrate your instrument? Well, you have to use a known standard, like a conductivity standard. You can easily calibrate the deflection on the locator to measure different varying degrees of conductivity. If you want to measure liftoff, you can get some known values, such as these liftoff shims to set up for measuring non-conductive coatings, such as paint. Now, while we're talking about the locator here, you notice the needle, and it gives you percent severity. Severity in what? Well, it's kind of up to you and what you calibrate the instrument to do. But the hawking on the left is an impedance magnitude instrument. So what that means is the severity or the amplitude of your change is going to be reflected in how much the needle moves. So although you can see if it's a big change or a smaller change, you don't know exactly what's causing the change because all it's giving you information-wise is how much something changed. Now, if you can control variables like minimizing liftoff by using a spring-loaded probe so the coil's constantly under pressure to contact the test surface, then you can be isolating liftoff so it's not a factor. Now you know that if you get a deflection on your display, that it's something other than liftoff. Could be a conductivity change, a permeability change, could be a thickness change. That's why you have to isolate variables with this type of tester, because there's a large amount of factors that could cause your needle to move. Now, if you shift over to this one, this is the Locator 2S. This is not an impedance magnitude tester. This is an impedance plane instrument. What's different about the impedance plane instruments is not only do they give you the amount of change, usually expressed in volts per division, but it also gives you a timing or a phase change. So what does that look like? Well, first, let's go over to the locator. We're going to take this probe and put in the material. I don't even know how to calibrate this instrument, but for this particular demonstration, I'll just show you that right now I'm balanced in the middle of the meter. And when I scan over a crack, you get a deflection on the needle right there, see? But if I wasn't looking at this cal block and knew that there was a crack in there, I wouldn't know exactly what's causing that needle deflection. These are, very sensitive instruments. So provided you calibrate them the right way and you're able to isolate factors you don't care about, they're very effective instruments. However, with today's instrumentation and technology, this is a very dated instrument, but some people still use it. Just depends on what your application is. So now getting back over to the Locator 2S, which is an impedance plane instrument. Got a probe here. Now let's watch what happens when I put the probe in the material. I get kind of a horizontal line deflection there. What I'm going to do is clear it and balance. So my null point, or impedance point, flying dot, whatever you want to call it, is in the center of my screen. As I change my lift off a little bit, you can see the phase or the vector or the trajectory of that impedance change is all horizontal. But watch what happens when I scan over an EDM notch. I get a signal that's large in amplitude, and it's also a phase that's very different from the phase of the probe motion, which is what you're seeing there. So if 0 degrees is my probe motion, coming in around, let me balance again for you. Coming in around 25, 30 degrees, you know, that phase lag tells you that it's a surface breaking crack with some depth to it. Now, as that EDM notch gets deeper, eddy currents that are deeper in the material are going to be affected, and therefore they are going to cause more phase lag, so that indication would shift clockwise. Now, what if we flip this block over? Now, it's not a realistic example because this is probably a 1/4 inch and we'd have a real tough time getting to the back surface of that. But if this was only 1/10 of an inch thick and I turned it over so my cracks were on the bottom side, and then I took a wide enough coil and used low enough of a test frequency, because we need all those things to penetrate, you know, some amount. So if I would scan it then and I was seeing a far surface flaw, then our phase would be much over to the right or rotated clockwise, because there's more phase lag with a far surface flaw. So the impedance plane instruments give you a lot of flexibility because you are able to separate the variables based on phase. Now, this is a single frequency tester, but I'll make another video with the MIS-27 where I can put up 4 frequencies, and then you can really see the difference between the phase changes between various frequencies from low to high. So these are both very versatile testers, this one being the most powerful of these two. And you can perform a lot of the same tests with the Locator 2S as you can with more modern instruments, but this one has all the basics. You know, if you've got a Lissajou and you've got a gain control and phase control, and you can apply filtering, high pass filters, low pass filters, you're going to have all the basic settings that you're going to need to perform most tests. With this particular tester, I've done liftoff test, conductivity test, weld scanning, and many others. So point of this video is just to point out that if you have a non-calibrated display, that just means you have more flexibility in your instrument. Thanks for watching. Stay tuned.